welcome to Algebra 2 Lesson 44. In this video, we're going to learn about factoring trinomials with a leading coefficient that is not 1 using the reverse FOIL process. So again, for those of you who took Algebra 1, you've seen this content before, so it's not too challenging for you, but you might just need a refresher on it. So how would we go about factoring this using reverse FOIL? If I see something like 3x squared minus 19x minus 14, and I want to reverse the FOIL process. So I'm going to factor this into the product of two binomials. And let's just write FOIL out for a second. So it's F for first terms, O for outer terms, I for inner terms, and L for last terms. So the first thing you would think about is the fact that this times this, okay, would give me this. Now, this is a pretty easy scenario because the coefficient of x squared is a prime number, right? 3 is only 1 times 3. Or if we were really thinking, it could be negative 1 times negative 3. But you don't want to put that there because that would complicate things, okay? And I'll show you that at the very end, what would happen if you put negative 1 and negative 3 in. So I just think about 3 and 1, okay? 3 and 1. Now, I've got an x involved there because it's x squared. So I would have 3x and then x. Okay, 3x times x is 3x squared. So we've got that down. And the order that I put this in wouldn't matter. If I put my x here and my 3x over here, that's completely irrelevant. The next thing, okay, the next thing that you would think about is the fact that the last terms, so this times this will have to give me this. Okay, it'll have to give me negative 14. So I would think about factors of negative 14, but it's got to be such that the outer and the inner are going to combine to give me that negative 19x. So that's where this trial and error is going to come in. I've got to go through all the possibilities. So for negative 14, I've got to think about positive 1 times negative 14, and I've got to think about negative 1 times positive 14. I've also got to think about positive 2 and negative 7. And then I've got to think about negative 2 and positive 7. Okay, so more scenarios are involved when you have something that's negative because it's a negative times a positive. You've got to go back and forth between the possibilities. So the only thing we can really do is just go through and do trial and error. So in other words, I would set up some scenarios. So I have 3x, I have my x, and let's just do another one down here. And sometimes I'll write out a bunch at once and just quickly go through the possibilities. So let's start with this positive 1 and negative 14. So plus 1 here, minus 14 here, and then you've got to reverse that. So you're going to go minus 14 and plus 1, because you've got to check different outer and inner products. In other words, for this one, I'd have 3x times negative 14 and 1 times x. Now, 3x times negative 14 is negative 42x. 1 times x is 1x. Negative 42x plus x is going to be negative 41x. So that's not going to work. This isn't a possibility. So you go to this one. The outer would be 3x times 1, which is 3x. The inner would be negative 14 times x, which is negative 14x. So negative 14x plus 3x is negative 11x. So that's not going to work either. So you can line that out and say, well, positive 1 and negative 14 will not work. So then you go to the other scenario. So let me erase this. And so in this scenario, we have a negative 1. So I'll put a negative 1 here and here, and a positive 14. So I'll put that here and here. So what am I checking? So 3x times 14 would be 42x, and the negative 1 times x would be negative x. So 42x minus x is 41x, so that won't work. For this one, 3x times negative 1 would be negative 3x. 14 times x would be 14x. So 14x minus 3x would be 11x. So this is gone. That's no longer a possibility. We can move on to the other scenarios. Now, when we get to this scenario here, again, we have positive 2 and negative 7. So plus 2, negative 7, plus 2. All right, so let's check this one. So 3x times negative 7 is negative 21x. And then 2 times x is positive 2x, and that would work. Negative 21x plus 2x would give me negative 19x. 2 times negative 7 is negative 14. So this is your correct factorization. Let me erase all this. I don't need to try anything else. And sometimes you hit it right away. Other times it takes you a while. But this is our correct factorization. And if you want, you can use FOIL and check it. 3x times x is 3x squared. Then the outer, 3x times negative 7 is negative 21x. Then the inner, 2 times x is positive 2x. Then the last, 2 times negative 7 is minus 14. If I combine like terms here in the middle, I'm going to end up with 3x squared minus 19x minus 14. That's exactly what I started with right there. Now, let me give you a little insight into why we wouldn't want to start out with negative 3x and negative x. I can factor out a negative 1 from this if I wanted to. I could say this is negative 1 times, and I can make this negative 3x and this minus 2. I just pull the negative 1 out. I'm legally allowed to do that. Then times, I could pull a negative 1 out from here as well. So negative 1 times, you'd have negative x plus 7. This is mathematically the same as this. Negative 1 times negative 1 is 1. So really, I could write this as negative 3x minus 2, that quantity, times negative x plus 7. So I could have began, if I wanted to, with negative 3x and negative x. So when you see something positive that's leading, you can do this if you want, but working with negatives in the leading position makes it a little bit more complex. You want to make things as easy as you can make them. So it's just better to start out with a positive here and a positive here. If this is positive, you know you can make that work because of what I just showed you. You can always factor out a negative 1 from each of those, multiply the two negative 1s together, and get 1. 1 times anything is just itself. And just to completely prove this to you, because I know some of you are like, no, that doesn't seem right. If you do FOIL on this, negative 3x times negative x is what? That's 3x squared. Negative times negative is positive. 3 times 1 is 3. X times x is x squared. The outer, negative 3x times positive 7, is negative 21x. Then my inner, negative 2 times negative x is positive 2x. Then my last, negative 2 times positive 7 is negative 14. So if you combine like terms in the middle, again, you would get 3x squared minus 19x minus 14. So again, that's why I just started out with this, because it's going to be the same as this, okay? And it's just easier to work with positives in the leading position. All right, let's look at another one now. And we did our first one, so it should go a little bit quicker. So we have 2x squared plus 23x plus 63. All right, so we're going to factor this into the product of two binomials. Now, my coefficient for the leading term here is a 2. That's a prime number, so again, that's a very easy scenario because I know 2 is just 2 times 1. And again, for the reasons that I just covered, I don't want to think about negative 2 and negative 1. So I'm just going to go 2x times x and be done with that. Now I just need to think about 63 here. What are the factors of 63? So what times what would give me 63, but then through the process of combining like terms with the outer and the inner, we would want to get a 23x in the middle. And for this, everything's positive, so I'm just going to think about positive numbers here. So 1 times 63, it's not divisible by 2, it is divisible by 3, so 3 times 21, not divisible by 4, not divisible by 5, is divisible by 7, 7 times 9, and that's all we're going to get. So lots of possibilities here. Now, if you think about this, this right here is very far apart if you think about the numbers. 1 and 63 are far apart. If I was multiplying 2 times 63, I'd have a really big number. Or if I was just multiplying 63 times 1, I'd have 63. This one isn't going to work. You can eyeball that and see that you can just eliminate that right away. Now, 3 and 21, I might be able to get that to work. I just have to check the different possibilities. So 2x, x, so 3 and 21. So I'm only going to check 3, positive 3 here, and positive 21 here. And because I'm only using plus signs here, it's much quicker. The other scenario is positive 21 here and positive 3 here. So check your outer and inner. 2x times 21 would be 42x. 3 times x would be positive 3x. This would combine to be 45x, so this isn't a possibility. You can line that out. For this one, 2x times 3 would be 6x, and then 21 times x would be 21x. So that would be 27x if we added, so that's not a possibility either. So we can line this out. So now our last possibility is to use 7 and 9. So I would do 7 here and 7 here, 9 here and 9 here. So the outer, 2x times 9 would be 18x, and then 7 times x would be 7x. If you add those together, you get 25x. That's not 23x, so this is eliminated. So it has to be this possibility, or it would be prime. So 2x times 7 would be 14x, and then 9 times x would be 9x. And if we combine 14x and 9x, we do get 23x. So we do get that, so this is the big winner. So let me erase everything. And again, you can check this through FOIL. 2x times x is 2x squared. The outer 2x times 7 would be 14x. The inner 9 times x would be 9x. 14x plus 9x would be 23x, so plus 23x. And then 9 times 7 would be 63. So you can see you got exactly what you started with. 2x squared plus 23x plus 63. All right, let's look at a few more. I think for most of you, you kind of figured this out by now. We're going to look at one where the leading coefficient is not a prime number. It makes it more tedious, not any more difficult. So 40x squared minus 172x plus 112 is what we're going to try to factor. Obviously, if you look, everything's even, right? I've got a 0, a 2, and a 2. But if you further think about this, you should know that 40 is divisible by 4 and 112 is divisible by 4. Those are obvious. For 172, forget about the negative for a second. For 172, well, 72 is divisible by 4, so I know 172 is. So that means I can pull a 4 out before I even start. So if I pull a 4 out, I'm going to have 10x squared minus 43x plus 28. All right, so I want to factor the inside of this now. So we'll have 4 times inside of my parentheses. Now, if I have 10x squared, it is not obvious what's going to go here and here. 10 is not a prime number. The factors of 10 are 1 times 10 and 5 times 2. And again, I know you could do negative 1 times negative 10 or negative 5 times negative 2, but we don't need to think about that, again, for reasons that we already covered. So I've got to go through and try, as different scenarios, 5x times 2x, or the other scenario I would have is 4 times the quantity. You'd have 10x and then times 1x or just x. So these are what we're going to consider here. It becomes more complex because the final term is positive and the middle term is negative. So what does that tell me? It tells me that to get this, I had to have a negative times another negative. So that tells me that these positions here are going to be negative values. So what are the factors of 28 considering only the negative values? Well, I know it's 1 times 28, so that would be, let me kind of just make a line here, negative 1 times negative 28. I know it's 2 times 14, so negative 2 times negative 14. I know it's 4 and 7, so we think about negative 4 and negative 7. And so that's all we're going to have. So let's start out with a scenario where I have negative 1 here, and I have negative 28 here. Now, one thing that I haven't told you, and I talked about this in Algebra 1, if there's not a common factor in what you're trying to factor, so in other words, we're trying to factor this. Forget about this, because you say, oh, there was a common factor of 4. That doesn't matter. We've already pulled that out. If there's not a common factor here, then none of the factors for this, meaning neither of these binomials would have a common factor. 2 and 28 have a common factor of 2. So this isn't a possibility. I can try the other alternative for this, which is if I have a 28 here and a 1 here. So 4 times the quantity 5x minus 28 times the quantity 2x minus 1. That's a possibility, but you'll see that we're going to rule this out right away because the outer 5x times negative 1 is negative 5x. And the inner, negative 28 times 2x is negative 56x. Those two are not going to combine to give me negative 43x, so that is not a possibility here. Now, let's erase that, and I'm going to move on to the next scenario, which is negative 2 and negative 14. Now, we can eliminate that right away. And why can we eliminate that right away? Well, if I put a negative 2 here and a negative 14 here, I've got a common factor of 2. If I switch the order of that, and I put a negative 14 here and a negative 2 here, still got a common factor of 2. And it's going to be the same thing when I get down to this if I need to. If I put 14 here and 2 here, common factor of 2. If I put 2 here and 14 here, common factor of 2. So either way you do that, in any scenario, this is eliminated. You don't need to worry about that. Now I want to check this one right here in this. And if that doesn't work, we're going to move on to this scenario. So if I put a negative 4 here and a negative 7 here, common factor of 2. So that arrangement cannot work. So then what I want to try is negative 4 here and negative 7 here. Let's see if that works. So I would have 5x times negative 7. That would be negative 35x. And then I would have negative 4 times 2x, which would be negative 8x. So it looks like that's the big winner. Negative 35x minus 8x is negative 43x. Right, that's what we want right there. All right, so let's erase everything. And we're lucky because we didn't have to go into this scenario at all. All right, so we found the correct factorization. If you want to, you can go ahead and check this. You could do 5x times 2x. That would give you 10x squared. The outer 5x times negative 7 would be minus 35x. The inner negative 4 times 2x would be minus 8x. Negative 35x minus 8x would be negative 43x. And then the last, negative 4 times negative 7 is positive 28. So that gives you this, and you're multiplying this by 4. And when you multiply it by 4, 4 times 10x squared would give you 40x squared. 4 times negative 43x would be minus 172x. And then 4 times 28 would be positive 112. So you get exactly back to this. All right, let's take a look at one final problem. And I gave you one here that has two variables involved. You've seen factoring with this before. You know at this point that it's not any more challenging, right? You can almost just ignore the second variable, work everything out, and then come back to it. So if I have 8x squared plus 34xy plus 36y squared, the first thing you would notice is that what? Everything is divisible by 2. So I could pull that out before I even begin. So if I pull out a 2, I'd have 4x squared plus 17xy plus 18y squared. And so once that's done, we want to factor this inside of parentheses into the product of two binomials. So I think about 4x squared. I know that can come from what? It could come from 4x times x, or it could come from 2x times 2x. So we've got kind of two scenarios here. And again, we're not going to think about the negative version, negative 2x times negative 2x, or negative 4x times negative x, for the reason we talked about earlier. All right, so let's do this one, or you'd also have this one. Now, once we've worked this part out, I know that y times y gives me y squared. You can just throw this in and forget about it. Okay, we know that from working previous problems. Y times y is y squared. When you do your outer, you get xy as a variable. When you do your inner, you get xy as a variable. So when you combine like terms, you're going to have a term with xy. So just put your y in there or whatever your second variable is and forget about it. Don't stress about having two variables. It's super, super simple. All right, so the next thing is to work things out. You know that you're just going to focus on this 18 here. And everything's positive, so I'm just going to focus on positives. And so I would have what? For 18, 1 and 18, 2 and 9, and then 3 and 6. Now, I've got to go through many possibilities here. So let's think about for a second what we can eliminate right away. For 1 and 18, it would not work in here at all, because I'd have to put an 18 in here somewhere, and it would have a common factor of 2. So it wouldn't work in this one. It might work in this one, but I'd have to try this configuration here, an 18 here, and a 1 here. So just think about 4 times 18, that would give us 72, and you'd have 1 times 1, which would be 1. So 72 plus 1 would be 73. So that's not going to work out in either one, so you can go ahead and get rid of that. All right, so let's erase this. Next, let's think about 2 and 9. So in the first one, I can't use it at all, again, because I'd have to put a 2 somewhere. I can't use a 2 here or here because I'd have a common factor of 2. There's no common factor in this right here that we're trying to factor. I know there's one up here, but again, we've already pulled that out, so there shouldn't be one in any of the binomials there. So it's not going to work there. In this one, I can put a 2 here and put a 9 here. I can check that scenario. So 4 times 2 would be 8. 9 times 1 would be 9. 8 plus 9 is 17. So we have found what we need. So let's erase everything. Let me just kind of slide this up so we can check it through FOIL. So I'm going to put my 2 out in front. 4x times x is 4x squared. My outer 4x times 2y would be positive 8xy. My inside 9y times x would be positive 9xy. And my last 9y times 2y would be positive 18y squared. Again, when we think about those two middle terms here, 8xy plus 9xy would be 17xy. So let's just erase this and put plus 17xy. And if I distributed that 2, I'd be back to 8x squared plus 34xy plus 36y squared.